So the next question is search in a rotated sorted array. So what does the question problem statement states? It states that we will be given with two things in the input. One will be this integer array over here and the other is this single integer target. Now what does the question demand? The question demands that we need to find the given target element in our array. Okay, and once we find the element, we need to return its index. That is our output. And if we do not find the element, if the target element is not present in our nums array, then we have to return -1. As simple as that. There is an extra thing that is told about nums, which is it is not exactly sorted as you can see, but the input array is some form of a rotated sorted array. What does this mean? See, over here I have taken a sorted array and I have rotated for k times. In the question, the valid range of k is 1 to n. That is, a sorted array can be rotated once and that can be given to us as our input, or it can be rotated twice or thrice, or up till n times it can be rotated. Also, one observation, just check it over here only. If the sorted array is rotated for n number of times, if it is rotated for k6, then you can see this the first one and the last one is same. If we rotate a particular array for n times, where n is the size of that array, then we get back the same array. So there is a possibility we get this array where everything is sorted, right? If it is rotated for k times, it will be the same array, it will be the sorted array. So that is also a possibility. That is our edge case. Okay. Now, coming to the brute force approach of this, obviously guys, we will be looking for the target element in each of the index. We will be traveling this array linearly and we will try to find out the target element. If we find the target element, we can return the index and break out from our loop. Or if we iterate through the whole array till the end and still we cannot find the element, then we can tell that the element is not present, and as the question demands, we can return -1. So this particular approach will take order of n time because we are linearly traveling through an array of size n. But we have to leverage somehow the sorted nature of this array and bring down this order of n time complexity to order of log n time complexity. That is our target for this question, right? Obviously guys, directly on this array I cannot deploy binary search, because suppose, let me take any case. Suppose if I take my start is at 0 and my end is at 4 for example, then my mid will turn out to be 2. So in this case, if I check that my nums of mid is obviously what? It is lesser than target. My target is greater than my nums of mid, because my nums of mid is what? 0 and my target is 4. So in this case, when the middle element is lesser than the target, so usually the target should present towards the right of the mid, because the target is greater than mid. But over here you can see the target, which is 4, is present to the left of the min. So normal binary search on this array we cannot do. We have to adjust something, we have to take certain things into consideration, and then only we can run binary search to decrease the time complexity. Directly we cannot use, that part is clear. Now for developing the intuition guys, I want to give you certain observations. Now in this question over here, if you see, if I just omit this case over here, the last case where the sorted array is only given to us, if I just omit that particular case, then you can see, if I draw a graph over where the axes are index in the x-axis, we take index in the x-axis and element in the y-axis. Okay. Now something like this is followed, that initially it will start from a big number, like a middle big number, and it will keep on increasing, right? And after a certain point there will be a certain dip and we will get our minimum number in the array, and then again from there we will be increasing, but we won't be increasing to greater than this point over here. Like we will increase up till this point, we cannot cross this point in this over here. If I cross this, then it will not be the rotated form of a sorted array. In pen and paper you can take an example and observe. So I can always say that it will grow from here, then there will be a dip, after that again it will grow, but not up till this level. But of course in the last case over here, if an array is rotated for n times, the graph will look something like this. This will be normal binary search stuff. But all the other cases, the rotated sorted array looks something like this. Now have certain observation, guys. Over here you can see that from this graph what I have said is the first element will always be greater than the last element. The first element, except for this case, this is the edge case, we will be talking about this later. For all other cases, the first element will always be greater than the last element. This is one observation. And the second observation is, guys, see, everywhere in this array there is an increasing sequence, but only at one particular position there will be a decreasing sequence. See over here, this is increasing, this is increasing, this is increasing, this is increasing. Only this is a decreasing sequence. Now if I try to make a bigger rotated sorted array, suppose 4, 5, 6, 7, 0, 1, 2, 3. If you rotate it for certain amount of time, you will see that this will become rotated. So this is a valid rotated form of a sorted array, right? So over here also, if you observe, increasing, 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 again increasing, increasing, increasing. Only in this portion over here, this is a decreasing sequence. So every time it will be increasing, and there will be one situation where the current element will be lesser than the previous element. There will be only one index like that. Okay. So these are the certain observations that you should be clear before moving on to the solution. Now coming to the approach, optimal approach, how we can deploy binary search on this. See, this is on the observations, the two observations that I gave you. On those two observations, I can figure out if, for example, at any point my start is over here and my end is over here, right? And my mid can land within any two portions, like it can be in this portion over here or in this part of the array. It can land in either one of this. How can we check in which portion it has landed? It's simple. See, if it landed over here, then the element over here should be greater than the first element, or the element which is at start, it should be lesser than the middle element if the mid has landed in this portion. But if suppose my end is somewhere over here and my mid has landed somewhere over here, so this element will always be lesser than my start element. So there are two possibilities. Either my nums of start, this can be less than my nums of mid, then I can say that my mid has landed in this portion. Less than equals to is also very important, guys, over here, because otherwise I'll tell you otherwise, this equals to is very important. After that, if this condition is not true, if the middle element, if nums of mid is less than the nums of start, then obviously I can conclude that the mid has landed in this portion. I hope this is clear. Now in whichever portion the mid has landed, I will always be having one sorted portion of my array. What do I mean? In whichever region my mid lands on, still either my start to mid, this particular range will be fully sorted, or my mid to end, this region will be fully sorted. If my mid lands in this region over here, then mid to end is sorted. If my mid lands over here, then my start to mid is sorted. Any one of these portions will be sorted, right? And also let me also visualize this thing to you, that maybe both of them are also sorted. What do I mean? Suppose if at any situation my end is over here, so if my start is over here and the end is over here, then the entire length is sorted. So from my start to mid also it will be sorted, and from mid to start end it will also be sorted. Another possibility, my start can be over here, and if start is over here and my end is over here, then also the mid that will be over here, that will be what? From start to mid also it will be sorted, and from mid to end also it will be sorted. So in worst case, any one of these should always be true, but there is a possibility when both can be true, right? So what I can tell is, if this condition satisfied, then my mid will be in this region. Till now, guys, I have not talked about target. Now if this range is sorted, I need to check if the target is lying in between these two. If my target is greater than this nums of start and less than this nums of mid, if that is the condition, that my target is over here, so I should bring my end to mid -1, right? Otherwise the vice versa, if the target is not lying in this region, that means it is lying in this region over here. In that case, I should move my start to mid +1. Also, if this particular condition is false, then I am sure that my mid has landed over here. then now I will check for the target. If my target is within this range, if it is greater than the middle element and less than end, then I will be it will be in this range and over here. Then I can bring my start to mid plus 1. Otherwise, if that is not the case, it will be over here, right? Then I should move my end to mid minus 1. As simple as that, guys. Now I hope with this particular information you will be able to code it up on your own. Please do try it on your own end. Otherwise your coding skills will not improve, right? Otherwise, if you have tried on your own, let's continue. So I will start with taking the length of this array, nums dot length. After that I will make 2 pointers. End start will be 0 and my end will be n minus of 1, the last index. After that I will start my while loop where the start will be less than equals to end until this condition is true. I will continue iterating through the array. First I will find the mid, which is start plus end minus start divided by 2. After that I need to check if we have found already the mid is pointing to the target element or not. That is a possibility. So if my nums of mid is equal to target, then over here only we can return the index of the target element, which is mid, right? After this whatever we discussed, we will start that. Basically what we discussed is that the mid will either lie in the first increasing zone over here, or it can lie in the second increasing zone of the array. So what is the condition to check it? I will check it that if my nums of start is less than or equal to, this equal to I will be talking about later. I already told you earlier that I will be talking later. If this is lesser than equals to my nums of mid, then I am sure that my mid has landed in any of these regions, right? So what I need to do, I need to check if the target is present within this range, then I have to move my end to mid minus 1, as simple as that. So if my nums of start is less than equals to the target and my target is again less than equals to nums of mid, if this is the case, so I have found out that the mid is within the first increasing range and also the target is in this range only. So I should move my end to mid minus 1. Else I will move my start to mid plus 1, because I am sure if this condition over here violates, that means the element is present towards the right of mid. Okay. Also similarly over here, okay, if this will be else if, right? This will be else if, because I am checking my if over here, then else if, and in the else portion obviously I can say that the mid has landed in this second increasing portion. In this second increasing portion mid has landed somewhere. So now I need to check if the target is also in this range, then I should bring my start, otherwise I will have to bring back my end. So I will check if my nums of mid is less than equals to the target and my target is also less than equals to nums of end, right? So both these conditions are necessary. It will rise in range, then my start should move to mid plus 1. Otherwise, else my end will move to mid minus 1, as simple as that. Now think about it, we are talking about the target after this condition is matching, right? We are first finding out in which portion nums of mid or mid has landed. After that we are trying to do all these operations of shifting the start or the end. Now if the element is found, if it is present in the array, somewhere down the line this particular condition will be true and we will be returning the index from inside the while loop. If not, if the element is not present, then I will come outside this and I will return minus 1, right? Let me quickly check this, then I have to talk about this equals to sign over here. Why is this important? Pretty basic stuff, you also can sit on your own and understand, but I will also tell you what is happening. Okay, so mid equals to start minus, right? Sorry, plus, right? So if I just run this now, it is accepted. Let me submit it as well. So this is betting 100%, right? Now let me talk about why this equals to sign is important. If this equals to sign is not there, then we will be getting a wrong answer at certain point, right? Why? because there is a possibility, guys. So about this case, let us take a simple array of 2 elements, which is 3 and 1, right? Now what I am saying is that my target is suppose 1, okay, target is 1, so my output should be 1 only, because 1 is the index in which my target element is present. So if I just dry run for this, our debate is in the condition of else if I have included the condition that my nums of start should be less than nums of mid. I have also given a equals to sign over here. The debate is on this equal to sign. So now see guys, if my start is suppose over here and my end is over here, then my mid will turn out to be over here. Then in this else if condition, what I will check, if my nums of start is less than equals to nums of mid. So less than condition, this nums of start is basically 3 and this is also 3. So less than condition will not be violated. So it all depends upon if this equals to sign is there or not. So guys, if you remember, this else if condition, entire this else if condition was designed to operate if the mid element lies in the first sorted part of the array, and if it is lying in the second sorted part of the array, then only we go to else. Whatever the operations were there inside else, that was for the second half of the sorted array, right? Because that is where the mid is lying. We would find out that if this condition does not match. So we can already feel that when this equals to sign will not be there, then this equality case will go to else part, but my mid is lying on the first sorted part. So already something is going wrong. We can assume here only. But over here, if we just continue in the else part, I will check what? In the else part, I will check if my target is lying in between start and mid. Obviously the target is 1, start and mid are 3. So obviously the conditions will be violated. Like this condition over here, this was what we are checking. This portion over here will be wrong. Equals to sign was also involved over here. So this condition will be false. So what I will do? I will go to the else part inside else part. So inside this else part, this condition will be false. So I will be coming to this portion over here. And if I come to this portion, my end will be going to mid minus 1, which is 0. It will go to minus 1 basically. End will go to minus 1, and my while condition that start should be less than equals to end, this condition will be violated and we will move out of this while loop and return minus 1. But I should have written what? I should have written 1. So I hope you are getting the problem. It will, if the nums of start is equal to nums of mid, that means the middle is placed somewhere in the initial sorted part of the array. There are 2 sorted parts of the array. If this condition matches, the mid is in the first sorted part. So I would allow my else if block to run. So I will put my equal to sign over here. I hope the thing is clear, guys. Thank you for watching.